Welcome to this example. So we have this weird figure here, and this example actually ties in Pascal's triangle. So what you learn in Pascal's triangle in kind of ordered counting. I'll put up a link up above there to Pascal's triangle and some kind of thought process behind it. So I think it's very useful because it is used in the application of counting the number of paths. It uses kind of the same concept. So, when you're doing paths, you can either have, sometimes you'll have like a checkerboard and you want to see when the checker is going to get to a certain point and how many different ways can it get there. Or, you have kind of communication links between maybe cities. And then, you have all of these communication links between cities and you want to know, okay, well, how many paths are there from one city to another in terms of the communication? So this is exactly it. Instead of cities, we have letters, but you can think of, A being a city, B being a city, C and D and so on. And these cities are connected by lines or communication links in some way. They're asking us in this question to go from A all the way to K and find out, okay, how many total paths are there to get from one point to another? So let's do that. So I am going to use the concept of Pascal's triangle in order to do this. So I'm going to be starting from right here and I want to be ending up all the way over here. Now you can draw the paths one by one and it would get annoying and extremely complicated in terms of, overwhelming maybe in terms of looking at the whole thing. So instead, what we will do is we're going to just create the paths from each city to the next. So for instance, to get from A to B, there's only one way to do it. Okay, so I'm going to put a little 1 there to go in this direction. Now, to go to C, okay, you will notice that there's only one way from B to get to C. Now we're assuming we can't just keep going back between cities, right? Once we traversed something, we're not going to be traversing it again, going back and forth, back and forth. So we're kind of, doing the paths which have the least amount, all right, okay, of the direction. So to get to C, there's only one way to get there from B, okay? So we're just going to be looking at this, okay, and then doing that answer right here. So now to get from B to D, there's also only one particular way. But now something interesting happens because you will notice that I can actually go. So I'm going to kind of change the color here. Notice that I can go from C to D, okay, in this direction, right? Now we know that to get to C there was one way, okay? And now to get to D, so to get to D right here, if it was from B, there was only one way to do it directly. But now, okay, if we consider both from C and from B, then we would say, okay, that's 1 plus the 1. So this is actually two different ways to get to D. And the two different ways would have been the AB, okay, to D, and the ABC to D. So those would have been the two different paths there. All right. So from C, okay, and then from B, we can get to D. Now you can do that also in the other direction in terms of getting to C. So I can get to C right here, going in this direction from D. So I can get to C from B and from D. And that would have been, so now notice, okay, that going in this. Now I can't traverse back, so I'm not going to be using this 2 right here because I don't want to go back, so I'm going to be using the green, so that's the 1 plus the 1. So this would have been 2 ways to get to C. All right, and that's something you're going to have to think about a little bit, okay? Now I'm going to go back, okay, and now we continue. So now to get to E, so I can get to E from C and from D. And notice there's 2 ways to get to C and then 2 ways to get to D if I count all the paths. So that's 2 plus the 2. So that means 4 total ways to get to E. And now to get to F, okay, so that there's only one way. Okay, so that would have been just 4. Okay, that's in this direction. And then that's going in this direction. So that's from E to G. So this is also 4, right? Because it's for this, but it's also going through F. So I have to add up the 2 nodes there. So I'm going to be adding this and this. So now this is going to give me 8. And now I can continue. So now there's only one way to get to 8. To get to H. And now it'll be 8 different ways because I'm just looking at the previous node. And now again, so now I'm going to be running into problems. Okay, so right here, notice that what I have is to get to J, so there will be 8 different ways, right, from H. To get to I, there's 8 different ways. To get from H to K, okay, there's 8 different ways, right? However, okay, now notice that you can also get to K from here. So that would have been 8, okay, going from J, 8, okay, going from H, and then 8 going from I. So in total, so that's 8 plus 8 plus 8, which is 24 different ways that we would have there. Okay, so that's an interesting example to be able to use Pascal's triangle in order to actually count the number of paths. And I would encourage you, to kind of erase this and then do it on your own. And in particular, understand what has happened around here. Okay, and then also understand what has happened around here to get to K. All right. Okay, so that was another nice example of Pascal's triangle application. Bye, everybody. Okay, so that completes the entire test. I think it's a good one in order to get you started on organized counting. I specifically put a lot of examples that are a little bit more challenging than the basic ones, which you probably will get in your courses of data management and probability. These ones will certainly challenge you in some way, and if you can do them and understand them, amazing. Okay, thanks for watching. See you in future videos. Bye, everybody.